Now we're going to be getting into chapter 9.6, which is graphing other trigonometric functions. In the previous section, what we were looking at were the parent function of sine of x and then the parent function of cosine of x, and then we were performing various transformations on them. So one thing that I do want you to remember, you are not going to be using notes on this test, so you're going to be responsible for being able to produce these sines and cosine functions. The period for sine, the amount of time that it takes for it to complete one full cycle before it starts repeating itself, is going to be the period of 2 pi. So that's for the parent function. 2 pi is how long it would take. And then same thing for the cosine graph. Okay. So then what we also discussed though is that's the typical period, but there could be some sort of multiplier directly onto that x. So let's say there was sine of 2x, for example. Then our period would have been modified, and you would have taken your period and divided it by whatever that multiplier was. Okay. Then regardless of whatever your period is, to find your key points, you would just take your period and quarter it. So for instance, for the parent function, we would take 2 pi, we would quarter that, which would be 2 pi divided by 4. When you simplify that, you would know your key point intervals, or your key points would be going by pi over 2. For sine, key thing to remember is that at the start, at 0, it's going to start at the midline. So at 0, we start at the midline. And then also the difference with cosine then is that at that start 0, you start at the maximum amplitude, which is going to be at 1 for the parent function. Alright, so with that in mind, what we're going to be moving on today, what we're going to be moving on with are graphing the cosecant and secant functions, and these are the kind of, if you could call them, parent functions of cosecant and secant. And what I do have are the steps for it, and what you'll see is with practice, it's going to be not anything too bad, but the steps here are you would, for cosecant, you would actually graph sine of x with the transformations. So at the very start, you're just going to transform whatever cosecant function you have into a sine of x function. You would do the transformations just like we did in the previous section. But then what you have to remember is you're going to draw vertical asymptotes where that function crosses the midline, and then parabolas at the minimums and maximums that open away from that center line. So this is what we're looking at. Cosecant of x, I would actually graph sine of x. So here is that parent function sine of x with no transformations done onto it. I would draw at wherever it crosses the center line, I'm going to draw my vertical asymptotes. So here is my midline, or my center line. Okay, and then opening parabolas away. Secant is pretty much the same thing except for your graphing cosine of x. So I am going to do a couple examples. We're going to do numbers 4 and 5. We're going to start off with number 4, and it's kind of looking a bit complicated, but you're going to find as long as you're comfortable with graphing cosine and sine, you'll be fine. So I'm actually going to graph the sine function. I'm actually going to graph the reciprocal function of secant, which is the cosecant graph. Remember, s goes with c, c goes with s when it comes to these reciprocal functions. So 1/2 cosine pi x over 2. Alright, so this is what I want to graph. So the first things come first, I need to find my period, which typically it is 2 pi. However, what you see is I have this multiplier onto my x, and really what I have here is pi over 2 times x. So I need to take 2 pi divided by pi over 2 when I multiply by the reciprocal. What I get is my period is 4. It's going to take a total of 4 units in order to get a full cycle for this. So then I need my key points. What do my key points go by? I'm going to take whatever I got as my period and quarter it. So I get 1. Alright, other things that are going on, I can see there's this multiplier attached to this whole thing. Oh, sorry, I'm focusing on the cosine. I can see that I have this multiplier, that's that amplitude. So I do have some sort of change in the vertical spectrum of this. It's going to be going up 1/2 and down 1/2 from the center line. There are no vertical shifts, there are no horizontal shifts, so at this point I am done. I'm going to go ahead and graph this. Okay, so why it was important for me to find my period is because that's what guides my numbering of my horizontal axes. So I do know that I'm going to go all the way up to 4, and then I do know that each one of these is going by 1. So from 0 I would go 1, and then 2 ones, 3 ones, and 4 ones. So those are going to be my key points along the horizontal axes. And then I'm just going to go back for the heck of it, because I can. Okay, so now I also need to keep in mind that my amplitude is only going to go so far up as 1/2. So I will label these -1 and 1, but then I'm going to keep in mind that I'm only going to go up 1/2. So cosine, parent function, as we mentioned at the beginning of this video, is going to start at its maximum. At the point start 0, we're going to start up at its maximum amplitude. Then cosine has that pattern going down to the center line, down to its minimum, back to the center line, and then up to its maximum. And this would repeat over on this side as well. Okay, and so I'm just going to draw this dotted because I actually was not setting out to graph cosine, was I? So this is going to just be the basic guiding or guidance for what I did want to graph, and that's this right here. I'm going to be looking, where does my cosine cross the midline, and in this case, since there is no vertical shifts, it's just crossing at the x-axis. That is my center line. So here's one asymptote, here's another asymptote, another one, oops, another one, and then at these maximums and minimum points, those are where I want to draw my parabolas that approach my asymptotes but never cross them. So, and I do want to open those away from my center line. So this is kind of what it's looking like, and then I can kind of draw a half one over on this side, half one over on that side. And what you can see here is I have 2 full periods, because here I started, this right there would have been the cutoff of 1 full period, because right at this point I would have started repeating myself. Okay, and then so here's another full period, so I have 2 full periods there. What your number 4 actually asks you to do is match up your given function with one of these A, B, C's, or D's. So now that you have this, you can just go and appropriately look at which graph matches up for your number 4. Number 5. Okay. Number 5 wants you to figure out what does the graph look like for negative cosecant of x. So using those steps as I outlined above, you're going to actually be graphing the reciprocal function of cosecant. You're going to be graphing negative sine of x. Okay, so this one I'm going to be looking at my period. That's the first thing to identify so that you can label your horizontal axes. So the period here, if there were something being multiplied onto x, which technically 1 is, it's negative sine of 1 times x, you would be taking your 2 pi divided by whatever is being multiplied onto your x. So since it's 1, we just have our typical period of 2 pi. Key points are going to be where we take that period and divide it by 4, so I'm not even going to do that work. Here we have it. Alright, amplitude. Amplitude is still 1 here. Because it's always positive. Remember, amplitude is just telling how far up and how far down from that center line you have to go to reach the maximums and minimums. But it is negated, so I am going to recognize here that we have a flip. It's a vertical flip. So I'm going to start graphing it. So this is why that period was important, because now I can go ahead and label a full 2 pi, and then I can quarter it, because that's how you always figure out your key point intervals. And then I know that I'm going by pi halves, so I would go 0, pi halves, 2 pi halves, which is just pi, and 3 pi halves. And I could have gone forward to graph 2 full cycles, but I'm just going to go backwards again. Okay, so you're going to see that I do have 1, 2, 3, 4, 5, 6, 7, 8 key points, 8 slash marks that will give me 2 full cycles graphed. So sine, what it does is it typically has an amplitude of 1, and it would start at its center line, go up to its maximum, but because this is flipped, I'm going to be going down instead, and then to the center line, up into the center line. Okay, I'm going to dot this again. Reason being is because I wasn't actually setting out to graph my sine. I want to graph cosecant, so this is only the guiding step to graphing now cosecant. So once you're done with graphing that reciprocal function with all the transformations, what you can then do is find out where it's crossing your center line, and again, because there was no vertical shifts up or down for this one, the center line is just at the x-axis. Oops. And then at those maximums and minimum points, you're going to be drawing parabolas that open away from your midline or your center line. Okay, so this right here, and these purple lines, if you ever graph this on your calculator, that's what would appear on your calculator.